All right, so this is the third installment, and what we're going to do now is talk a little bit about how replication happens. This is a famous experiment by Messelson and Stahl to talk about how DNA is exactly replicated. So up here in this picture, you can see Messelson and Stahl, and actually this person laying here with their hand over their head, which you don't realize, is that is actually Chase from Hershey and Chase. They all worked in labs together up in around Berkeley, and so they were all friends. And so that's actually who's laying here in the picture in front of them. But anyway, so what I want you to get from this is there are three different ways that DNA could replicate itself, and at the time it wasn't sure. And so what they're showing you here is the three different models. One is called the conservative model, one is called the semi-conservative model, and one is the dispersive model. And the conservative model means that we have a parent DNA cell, the double helix, and then after the first replication, you have basically one DNA molecule that's old and one that is brand new material. The semi-conservative model means that there is a little bit different, that a new DNA replicated molecule is half one strand old, one strand new, and that's called semi-conservative. And then the third one is the dispersive model, which means that each new DNA molecule is made up of parts of old and parts of new spread throughout the molecule. So what they ended up doing was they ended up actually making part of the molecule using isotopes, heavy isotopes and light isotopes, to see where things ended up. And what they realized is they proved that the semi-conservative model, half old, half new, is actually what happened. So I do want you to know that Messelson and Stahl, semi-conservative. Okay, and so here they're showing you the heavy nitrogen, basically. And this is what they ended up with. And so this is what I want you to know, semi-conservative. All right, some definitions before we go on. There's origins of replication. What you need to know is for DNA to be replicated, it has to open up. And those areas where it splits open are called the origins of replication. In bacteria, they have a single circular chromosome, so there's a single origin of replication. In us, though, we have 46 chromosomes, and they're extremely long. And so what happens is we have multiple origins of replication on each chromosome. Okay, so need you to know that. And then I need you to look at this picture also, where you can see it's pushing to the sides. And so wherever those two sides are together, that is called the replication fork. So there's a replication fork on the left and there's one on the right. And then the origin of replication would have been where the dot was. That's where it first opened. Okay, so again, replication fork, like a fork in the road. All right, the other thing that is not real clear, but it'll show up in other pictures, is it makes sense that the weakest bond in the DNA molecule are those hydrogen bonds that go down the middle. So it makes sense that it will actually unzip, is often the term they use. That's where the break is going to happen. And so it does. So it's going to happen right here between the there's AT and C's and G's, the 2 or 3 hydrogen bonds that are formed. This is the weakest link. Here we have covalent bonds, phosphodiester linkages. And so this is where it's going to break. The other term I need you to know is anti-parallel. Remember, we use that the strands are complementary, that you can predict. The other thing you need to know is the anti-parallel, that they go in opposite directions. And you can see this by the positioning of the carbons on the sugars. You can see the sugars, the second one is facing straight down, and here it's facing straight up. So again, we're looking at the 5' and 3' ends, and this is going to become important. So it's the 5' end with a phosphate group attached here, and here we have the 3' end with an OH pushing out there. This is going to become important because I'm going to say this several times, I hope or think, is that new DNA nucleotides can only be added to the 3' prime end. It cannot be added to the 5' end. So all strands, any strand is built in what we call the 5' to 3' direction. New nucleotides are always added to the 3' end, something you need to remember. All right, and then what we're going to talk about is DNA can't also, when it replicates, cannot start itself. So actually what happens is it has to be started by a piece of RNA. And it turns out it's usually about 5 nucleotides long, and we call these things primers. And there's an enzyme that does that. It's called RNA primase. Once the primer is put in place, again, that's also built in the 5' to 3' direction. Then we can start building DNA by putting it on the ends of the primer. So then DNA will start to be made 5' to 3' direction. Okay, so RNA primer. All right, we'll stop the share and then stop the recording.